Hello, Aaron.
Hello, Louise. Come here.
So, what would you like to ask Louise?
Aaron, can you explain to me about what is graph?
Of course I can. In mathematics, graph theory is the study of graphs, which are mathematical structures used to model pairwise relations between objects. A graph in this context is made up of vertices which are connected by edges. A distinction is made between undirected graphs, where edges link two vertices symmetrically, and directed graphs, where edges link two vertices asymmetrically. Graphs can be used to model many types of relations and processes in physical, biological, social, and information systems.
Can you explain about the computer network as graph model? What is the connection between them?
In computer science, graphs are used to represent networks of communication, data organization, computer devices, the flow of computation, etc. For instance, the link structure of a website can be represented by a directed graph, in which the vertices represent web pages and directed edges represent links from one page to another. A similar approach can be taken to problems in social media, travel, biology, computer chip design, mapping the progression of neurodegenerative diseases, and many other fields. Any question, Louise?
Yes, Aaron. Can you explain me about crossing number problems?
Okay. So, when the graph has a pair of edges that cross, it's known as a crossing on the graph. Counting up all such crossings gives you the total number for that drawing of the graph. Therefore, one of the main problems is to minimize the number of crossings by adjusting the positions of the vertices. This is usually done to improve the readability of graphs or to solve some real-world applications such as VLSI and circuit board design, or road, or railroad crossings. The minimum number of crossings in any drawing of a graph is known as the crossing number. Computing the crossing number is an NP-hard, non-deterministic polynomial time hardness problem, which means there is no algorithm that can find the minimum number of crossings of any graph in deterministic polynomial time. For rectilinear complete graphs, we know the crossing number for graphs up to 27 vertices, the rectilinear crossing number. Since this problem is NP-hard, non-deterministic polynomial time hardness, it would be at least as hard to have software minimize or draw the graph with a minimum crossing, except for graphs, where we already know the crossing number. In all other cases, it is best to have a triangular convex hull. You can discover why by manually drawing complete graphs with a low number of vertices.
Well, thank you for the explanation.
Wait, let me explain a little more about graph. Usually when someone talks about graphs in mathematics and computer science, they are referring to something like this. What we have are vertices, also called nodes, shown as the colored dots in these images, connected by edges, shown as the lines in these images. There can be any number of vertices which may or may not be connected by edges. If every vertex is connected to all other vertices, then it's considered a complete graph. A bipartite graph is one in which each vertex belongs in one of two sets, and vertices of the same set are not connected by an edge. This is usually shown by coloring the vertices, i.e. red and blue, where red vertices can't be connected to other red vertices. Depending on how the edges and points are drawn, you can create various types of graphs. Some examples include on the plane with straight edges, rectilinear, a graph containing no cycles, tree, all vertices on a line with curved edges, book embedding, or in some other space. One important thing to note, is that moving the vertices of a graph only changes the appearance of the graph, but it's still the same graph.
Wow, thank you so much for the explanation, Aaron.